Okay, this is Ray Puga with DownStream. We are ready to start our session. Our session is using 3D to predict manufacturing results. Our presenter today is Rick Almeida. Rick is one of the founders here at DownStream, and as I described Joe Clark as our blueprint guru, I would say Rick is our 3D guru, amongst other things here. So Rick will give you a good demo on how we are using 3D now and probably some ideas of how we can use it more in the future. And with that, I'll turn it over to Rick.
Thank you, Ray. Hello, everybody. Thank you for joining me this afternoon. What we're going to cover today is an overview of our 3D capability. Everybody has 3D, so this isn't an attempt to sell you something. It's part of your product today, whether you have CAM 350 or Blueprint. And what we want to do is explain what DownStream's 3D is for CAM, why we did it, and why we think there's benefits in using it to help predict your manufacturing results. So the 3D technology was released with CAM 350 version 14 and Blueprint version 6 in the fall of 2018. It was provided as part of everybody's upgrade. If you had maintenance, everybody received the 3D capability as part of that upgrade. Every new system we sell at this point has the 3D capability in there. Today we're focused predominantly on the CAM 350 end, more so than Blueprint, since Joe Clark had already covered that in an earlier presentation. So this deals more in CAM 350 with bare board rendering. And it really is no model required to generate 3D. So a lot of people think that when you're dealing with 3D, you have to have large step model libraries and so forth. This does not require models at all. You may have noticed if you're using version 16 or version 6 Blueprint, there's a new 3D viewport that has been implemented in it to navigate the 3D modeler, as well as a new stack-up visualizer. So we felt that with 3D, it was applicable for a couple different reasons. One was basic visual inspection of looking at the design in a new way. We thought it had benefits as well in verification, particularly when trying to run DRC or DFM on negative planes. We felt that 3D would provide much more clarity in resolving issues that you may encounter during DFM analysis. Stack-up definition, whether it's a simple two-layer board or a very complex multi-layer board with blind and buried vias and back drills, the stack-up visualizer had a lot of benefit there when using 3D. Because we're modeling the PCB, we also felt that could be extended to model the PCB panel for production. And finally, we felt that 3D had applications in documentation, not to replace 2D documentation, but to augment it with more information using 3D models. So why 3D in post-processing? The biggest reason is we felt that anything that can improve the likelihood that the finished PCB can match your original design intent was a good idea and something worth investigating and developing. The second reason was that 3D is used a lot now in PCB design. And we felt it's important, just like with flex design and so forth, that if something's being done in the design world, we needed to maintain continuity when you moved into post-processing, either in CAM or in documentation. So if more and more designs are being done in 3D, we thought it would be detrimental to force users to go back to a 2D environment to understand what their Gerber issues are before going to manufacturing. Excuse me. Funny thing about the design versus the finished PCB. Many designers refer to the PCB design database as kind of the holy grail for all your design intent. And it's true. But before we go to manufacturing, we do a very odd thing to that holy grail. While the design has a lot of interrelationships between components, pins, nets, and planes, and so forth, what we tend to do is strip all that intelligence out into unintelligent Gerber files or drill files send that off to a third-party manufacturer with documentation and expect them to reassemble all that information into a finished PCB. And now, there's really nothing wrong with this process. It has worked. It's worked for years. We just think that we can make this process better and more foolproof using 3D technology. So one of the things everybody, I know always looks at the Gerbers when they're ready to go to manufacturing, and Gerber viewing is a big issue. But even though we're looking at Gerber and we're inspecting for opens and shorts, adequate solder mask coverage, or making sure that we have solder mask in the right places and not the incorrect places, or making sure we have nomenclature on the silk screen, really what we're trying to do is we're mentally trying to picture what the finished board is going to look like so that we don't have any errors or disconnects between what our intent was and what comes back from the board fabricator. So what we want to see is a finished PCB. In reality, what we're actually looking at when we try to do this is we're looking at a top-down Gerber view of all the different design information contained in the manufacturing files. So it's kind of an incomplete picture. So when you're looking at Gerber, you're kind of restricted to either viewing your design either top-down or bottom-up. And a lot of times that's okay. In some cases, it creates unique challenges. For one thing is, when you're looking at top-down or bottom-up, it's hard to discern which pads and which holes are actually through holes or blind and buried vias or unplated versus plated. Negative data is very difficult to visualize because you're always mentally translating that as to what it would look like in positive data. You're also looking at just the manufacturing files. You're really not able to see what that construction material is that's holding that circuitry information together in the construct of the PCB component. So Gerber only gives us kind of, essentially 66% of the view of the physical PCB. That additional D, the third dimension, provides a lot of benefit when we can add it to manufacturing. It now allows us to look at the board from any angle, including in between layers. It allows us, because we can look in between layers, we can start to think about what would dielectric materials and construction materials also look like in this unfinished PCB. We can take Advantageous and render negative data into a positive format, not convert it, but show you what it would look like in that finished PCB component. And obviously, because we were able to look at the board into 3D, it's easier to discern what might be a blind and buried via, what might be a through hole, what might have a back drill. So 3D gives us more information to be able to determine whether the design is ready to commit to manufacturing. There's also additional advantages of modeling CAM data in 3D. As I mentioned earlier, the stack up where we can view the construction intent. Without having to look at all the design information, we can now look at materials and attributes belonging to those materials, as well as thicknesses for individual layers. All this plays into what your finished product will look like. How is that manufacturing information integrated together to form a finished PCB? Where do the drill files go? What are the drill ranges that belong to that design? It helps a lot with visual inspection to be able to see how that manufacturing information is going to be combined to produce the finished circuit. Verification. Especially when it comes to things like negative planes. We talk a lot about, what happens when you have starved thermals. When you look at that in a negative format, you have to, again, mentally translate that data to positive format to understand why it's starved. With 3D, we can now really see what the construction copper clad will look like when it's finished. And a lot of that information becomes very apparent because we're now able to view it as how it would appear when the finished board would be returned. Panelization is another area that there's advantage to using 3D. Not so much to look at the one-up PCB, but to look at how all the various PCBs on that panel are interacting with web routes and so forth, and conflicts that you may have on the manufacturing panel. And the last, enhancing your documentation specifications, not replacing 2D drawings, but adding a third dimension to it to provide more clarity to your manufacturer, whether it's an assembler or it's a bare board fabricator, to give them more information, again, to make sure that you're getting the finished product back the way you intended to see it. So why is 3D CAM different than 3D CAD? Like I said, everybody is starting to move to 3D design in the PCB design world. But in that case there, the models or the database is really being used to model the 3D design. So it's done primarily for manufacturing conflicts and also to give better clarity during place and route. And it works great in that capacity. What we're doing in manufacturing is taking the manufacturing data and modeling that to create a facsimile of the bare PCB. So it doesn't replace what's being done in 2D design. It augments it by allowing a third dimension to be viewed when dealing with your manufacturing data. And how do we accomplish that? Well, like I said, we use manufacturing data to create a PCB model. Instead of using layer tables, we make the stack up of the PCB more of an integral part of the 3D rendering. This allows us to implement missing data that typically isn't found in your Gerber information, like dielectrics or prepregs and so forth. We show how that negative data will appear in the actual PCB by rendering it in a positive. And we can colorize the PCB to look more like a natural PCB as opposed to a CAD design. The way the DownStream 3D works is pretty much the same way it works when just viewing 2D data. Whether you're using unintelligent Gerber files or you're using an intelligent design file like IPC 2581 or ODB++, the data is imported. You immediately go into the stack-up visualizer. Whatever you do in that stack-up visualizer defines what that 3D model will look like, and the 3D model is rendered automatically. So there's not much more you need to do to view your design in 3D than you already do to view it in 2D. A lot of that is handled automatically. The stack-up visualizer itself is really the key for that model generation. As you all know, if you're outputting Gerber files, unless you have really strict standards, a lot of people will just output all your Gerber files as GERB1, GERB2, GERB3, GERB4, or ART1, 2, 3, 4, etc., without putting specific names on it. So when you read that data into CAM 350, or really any manufacturing tool, you have to spend some time to tell the system what file is actually what layer related, what it's related to in the stack up. And that's typically done for any 2D visualization, but it also is integral for 3D visualization as well. One of the things we do in the stack up visualizer is also allows you to fill in the blanks in between those artwork files by defining how those artwork files are going to be. Are they going to be part of a core? Is it a foil? Where does the prepreg go? And so forth. Drill definitions are the same case, especially with dealing with blind and buried vias. A drill file is a drill file. It's basically a list of X and Y coordinates that tells an NC drill machine to plunge and make a hole here and make a hole there. One drill file doesn't know it's a blind and buried drill file versus a through hole. We have to tell this to the system. The stack-up visualizer allows you to do that both graphically in a table format as well, and also to generate a 3D model of that stack-up for the same reasons, to be able to look at it in a different way. So the stack-up visualizer has a number of different benefits. One, it's a graphical stack-up visualizer. Like I said, you can still work in a table format, but you can also work in a graphical format as well. We supplement CAM data to give you more accurate modeling inside of your 3D, and really it's up to you whether you want to do that. But one of the benefits of doing it in the stack-up visualizer is you can either export that stack-up and send it to your manufacturer and confirm with the manufacturer that they can support what you're trying to design, or you can take a stack-up from that manufacturer and read it into the visualizer and marry it to your manufacturing files. So it provides a number of different benefits, and it's a key part of verifying manufacturing data before going to fabrication. The 3D viewport that has been designed, it does a number of different things. It sits alongside the 2D viewport. It has things like, allowing you to do cutting planes in the X, Y, and Z dimensions, giving you camera angle control, allowing you to display different thicknesses and dielectric visibility, whether you want to view the 3D model as a natural PCB, as we call it, or in more of its native CAD mode, where the top side is a red layer and the bottom side is a blue layer. excuse me, but it's always kept in sync with the 2D information. So, like I said, there's not a lot really that you have to do to generate a 3D model. It's really understanding that it's there and how to make the best use of it. We've implemented also a number of PCB-specific 3D features. And this is just because we know that we're dealing with PCB. It's not a mechanical system where, we might be designing a wire harness one day and a motorcycle the next day, for instance. We know we're dealing with PCB, so we can take some shortcuts to make viewing 3D PCBs a little easier. One is the ability to define layer group color sets. And what this means is that you basically are attributing your layers to say this is a solder mask or a silk screen or a copper layer. Well, if I can do that, then I want to say, well, I want all my copper layers to be copper. I want my solder mask to be green. I want my silk screen white. I want my dielectric to look like, fiberglass. And I want to be able to turn that on and off as I need it. And I may have other designs where I want a solder mask to be blue and the silk screen to be yellow, so I can save those away. And as I mentioned earlier, being able to take negative data and render it as positive. Again, it doesn't convert the information. It just gives you clarity on what that data will look like when it returns back from the fabricator. Because we have a PCB model, we can now also expand the layers in between that PCB model to see what's going on underneath the hood. So here we can see what individual parts of the circuit will look like, from an inner layer to a bottom layer to a negative plane. We can clearly see what the via ranges are and how your dielectric materials and your construction materials fit into all that. Another feature we added specific for PCB is layer peeling. And what this does is, let's say I have an 8-layer board, well, I can quickly just peel off from the top each individual layer to quickly scan what that layer looks like and then quickly reapply it without having to go back and, set up different visibility settings, for turning routes off on the inner layer and so forth. I just want to remove a layer and look at the model and then put the layer back. So there was a number of features that we added to 3D just to make it easier to navigate around the design to understand what's happening with your manufacturing data. We think that 3D has applications for any design, whether it's a 1x1 simple board with no solder mask or silk screen, or something more complex. And as the design complexity increases, we think 3D has more advantages to it. So anything with like multi-layer, high speed, where you're doing control or matched impedance, and thicknesses and layer placement is very critical. 3D can provide a very unique advantage over just using 2D. Now, we're not advocating not to use 2D. We're just saying here that 3D can provide more clarity for that. Complex via and drill structures, blind and buried vias, back drilling, those things are becoming more and more important to understand how they work inside of the design. Not just to send the design to manufacturing, but making sure that the way you've structured and you're telling your manufacturer how to set up those blind and buried vias can actually equate to something that the manufacturer can produce. Also, with flex, rigid flex, and embedded components, 3D can add a lot more capability than just your traditional 2D. So you can set up different zones inside of the stack-up visualizer, the stack-up visualizer to say this section of the design is rigid, this section is flex, this section is also rigid, but it's a higher layer count and so forth, and they're all interconnected together. So as designs increase in complexity, 3D becomes more advantageous to implement. So as we talked about stack-ups, we talked about PCBs, the next evolution in that hierarchy is to take that PCB and step and repeat it for panels. Again, not to look at the individual board itself, but to look at how the board is laid out on a panel, specifically to analyze where your mill routing is, where your breakaways are, where you may have components overhanging those breakaways. Where are your coupons? How do they integrate in? And if you can see here in this example, I've got a set of coupons that just seem to be floating in air. So it tells me that some work has to be done to this panel before we can actually produce it in fabrication. But again, it comes because we're going from the stack up to the one up, and it becomes very easy to take that same model and extrapolate that into a PCB panel. Using that model in documentation. So whether you're in CAM 350 or you're in Blueprint, we have this PCB 3D model that we can use. In a very basic way, we can export that design and share it with the design team, just as a 3D PDF and as an informal document. It doesn't have to be part of the release package. It just allows you to export it. You could even send it to your manufacturer before you send the files to them for them to take a look at. If you want to go further, you could send that document with your fab drawing to the manufacturer to get some confirmation that what you're sending to them can be built. If you're using Blueprint, you can add that 3D model as another reference inside of your fabrication drawing and make it more part of your formal documentation process. On the assembly side, we do some component generation in addition to importing a full step model, but it gives you more 3D perspective for assembly drawings and so forth. So depending on what your design flow is and how you're interfacing with manufacturing, you have a number of different options on leveraging that 3D model and sharing it to get confirmation that what you're designing is going to be what you're going to receive back from the manufacturer. Inside of CAM 350, and as part of your system today, is a 3D PDF export. And what this does is it takes the design database, the 3D part of it, it exports it into an Adobe standard format, but it becomes an interactive document. So what that means is that whoever is looking at it can also click on the 3D model, they can spin it around, they can view it different angles and so forth, and they can understand exactly what it is that you're trying to get back, as opposed to just sending them a fabrication drawing. So we're getting down near the end here, but I know one of the things that always comes up is a lot of people ask, what about step models? And why don't we use step models? So when we looked at building 3D, we looked heavily at, how do we leverage information from the CAD system going into either CAM 350 or Blueprint for post-processing. And the reality is that there is no real ability to export intelligent 3D data from any of the CAD systems today. So you can either export a 2581 file, or you can export ODB++, but that's really dealing with the bare board. And in reality, STEP's strength is in the component model rendering. The PCB itself, as far as STEP is concerned, is just another electronic component. And even if I can spread layers with STEP, it doesn't understand what nets are and what pins are and how they're all related together. But CAM 350 does. So we end up doing our own native, basically, rendering of the bare board. For Blueprint, we allow the importation of a STEP PCB in Blueprint to apply to documentation. And in the Blueprint case, that allows you to toggle in between the native rendering and the step rendering of the design, and either use both of them or one or the other in conjunction with your 2D documents. Again, not to replace anything, but to provide more clarity for manufacturing. So, should you use 3D in your process? Our answer is yes, especially if it can benefit by closing the gap between what you're designing and what you want to expect to get back from manufacturing. There's no cost in using it. It's very low risk to use. Like I said, it's getting a 3D model in CAM 350 is not much different than generating a 2D Gerber view. You spend time layering orders, defining drill ranges, and that 3D model is there. It's a question of how far you use it and rely on it with manufacturing, and that's really up to each individual user out there. But even small, less complex designs can have benefit just by being able to see it in 3D and what it's actually going to look like. Even if the full 3D suite doesn't make sense, there are pieces in here that can be a benefit. And again, the purpose of this presentation was just to increase awareness of what this tool was for, why it's there. It's not just to do an ooh and ah type of feature, but it does have a lot of key benefits that can be used with very little overhead to get to that result. So that is the snapshot of DownStream's 3D capability. We can open it up for questions at this point if we haven't answered it all yet.
Okay, Rick, thank you. Let's see here. I have a question, and I think you may have addressed this. Do the viewers support it as well, the free viewers of DownStream's tools?
The free viewers don't support it. The future viewers that, as I mentioned in my first presentation, when we go to a universal viewer, that will support 3D capability in it. But the free viewers do not support 3D. And the reason for that is we license a lot of the engines to generate the 3D model. So there's a cost for us to license that. We would have to charge for the viewer. If you buy a base Cam 350, which is the very low-end model, the low-end configuration of Cam 350, that does come with the 3D capability in it, but the free viewers do not.
All right. Can you peel away any board items to view only a single critical signal path or net with its reference plane?
Yes, you can turn nets on and off. You can turn components on and off as well. So there are a number of different visibility settings that are inside of the product to allow you to query that and see where that net is transgressing through the board.
Okay, and I'll just add to that to the user in my demo yesterday, or actually on Tuesday, we actually showed a trace with no reference. Basically going off a plane separator, and we showed that in 3D. So nice. Really kind of cool. I didn't even know it would look that cool when I did it. So.
Well, as I said, what's nice about it is that it's integral to the system. It's not optional, but it gives you a different viewpoint and a perspective to understand how your signal, how your design is going to look when being fabricated.
Is it possible to render also own graphic layers into 3D? I think that's if you have your, maybe it's layers that you've created inside of, say, Cam 350, maybe a selective solder layer or something like that. Is it possible to do that in the 3D view?
So it would, but you would have to attribute that layer as part of the design. So what we're looking for is what are the signal layers, what are the masks, what are the screens that are being used. So if you were to attribute that layer as another signal layer, it would get added to the stack up and part of that model.
Okay.
So for example, if you took a DXF design of an airplane and you just read that in as DXF, you would not see a three-dimensional airplane floating up in the 3D viewport. So we're not modeling that. We're modeling the manufacturing data for PCB fabrication.
Just waiting to see if anything else shows up here. Oh, here comes another one. Can you render views to look more like a classic drawing instead of the photorealistic pictures?
Yes. So that you would deal with different color settings. And you can also generate the 3D model as a wireframe as opposed to a rendered finished PCB. So you have that flexibility there. It can be looking like a black and white example, where you just want to see the top side, as it would if you were looking straight down. You can generate that model as well.
Yeah, and again, I'll add to that. I think in Joe's presentation yesterday, we actually, from Blueprint, we showed how in Adobe you could even turn on the wireframe if you wanted
right.
to.
So inside of Adobe, there's a number of features specifically not for PCB, but for dealing with 3D models. And we support a lot of those features when you export into the Adobe PDF. I
want to thank Rick for his presentation today. Thanks, everybody. I think everybody in here was here for almost all the sessions. So thank you again from DownStream for attending.